Yes.
Can you go over limits with cosine, like with
Sure.
trig function?
So, hold on, let me just get a whiteboard here. So do you have a problem? You have a specific problem, or?
Yes, the letter D on our homework 14A.
Can you read it to me? Because I don't have it
Yes,
up
it
here.
says the limit of x
Oh, wait,
towards
wait, wait, hold on,
0.
wait. The limit as x goes to 0.
And then it says cosine 2x over cosine square of x.
Oh, yeah, that's the same one that I got asked this morning in my other class. That's interesting. Okay. So, remember what I said about what are the steps? So what's the first step in trying to figure out what a limit is?
We plug it in.
Okay. So let's see what happens when we plug it in. We get cosine of 2 times 0 over cosine squared of 0, right?
Mm-hmm.
So what's the cosine? So and this becomes just cosine of 0, doesn't it?
Right.
So what is the cosine of 0?
It'll be 1.
Right. And then cosine squared of 0 is just 1 square, which is 1, right? So this equals 1.
Right.
And that's it.
Okay.
So for this one, there's nothing really to do because if you do the first step, which is just plug in the value, it evaluates.
Right. Okay.
If it didn't, there would be more work to do, but that's it. It's done.
Okay.
Does that make sense?
Yes. Mm-hmm. I just thought it was a little too simple.
Yeah, it's that simple.
Okay.
It really is. Okay. Thanks for asking.
Oh, also, as well as number C, if that is just us plugging in as well.
I don't know what C says.
Oh, I mean, it's on finding the velocity.
Find the velocity.
Oh, I think that might be, I don't think I could do it with you since it has to do with the values for for the first two parts of number 1. So maybe I could go over it with the LA.
Okay, let's do that. How's that? Just because it sounds more like there's not a specific question.
Right.
Okay, yeah, just go over with the LAs.
Okay. I'll be sure to do
Okay.
that. Thank you. Mm-hmm.
Okay, sure, no problem. What else? Any other questions about anything?
I have a question.
Sure.
So how do we know what parts don't matter when the limit is approaching infinity or negative infinity?
So this is what we're going to go over today.
Oh, perfect. Never mind then.
Yeah, today, that's what our lecture is today. So hopefully by the end of today, you will hopefully know how to do all that. And ask any questions along the way.
Okay, thank you.
Of course. All right. Any other questions? Okay. So I guess I'll start. Okay, so we're going to talk about limits at infinity, which are really what horizontal asymptotes are. Remember, we talked about horizontal asymptotes as being n behaviors. So that's the same as saying limits at infinity, right? As x approaches infinity, x approaches negative infinity. Make sense? All right, so now, if we look at this graph, we can see the one on the left. As we approach negative infinity, this graph is approaching y equals L, which is our horizontal asymptote. And the same thing is true for the one on the right. Okay? So, and also just to say You can also have more than one asymptote. Someone's mic is on and you're making noise. I don't know who it is. Can anybody, one of the LAs, can you see whose mic is still on? Okay, looks like it's gone. So we can see that here that the limit as x approaches minus infinity for both of these graphs is equal to some L. And if I call this M, I can say the limit as x approaches positive infinity of f of x is equal to M. Does that make sense? Just visually. I guess that's a yes. All right, so the line y equal L is called a horizontal asymptote. We've already talked about horizontal asymptotes. So this is in calculus what a horizontal, how you define a horizontal asymptote. Now, right here, this basically is talking about if we have some r here in this function that is greater than 0 and it's a rational number, which just means it's not irrational. It's a rational number. Does everybody understand what a rational number is? Can anybody tell me what a rational number is?
You could review it and I would be happy.
Is it a number that you could divide evenly?
No, that would be an integer. So a rational number is anything that can be turned into a fraction. Anything that is equal to a fraction. So for example, what I mean by that is you have some p over q where p and q are elements of integers. Remember I said z always means integers. And of course, q is not equal to 0. We can never have the denominator 0. So you can have a lot of things. Anything that is a fraction is automatically a rational number. But you can also have a decimal. So a decimal that is a terminating decimal is a rational number because let's say it's 0.5, I can say that equals 5 over 10, right? And no matter how many, if I have 0.53, it's 53/100ths, and so on. So anything I can turn into a fraction. A repeating decimal also, say, for example, 0.3333 infinitely is equal to 1/3. So repeating decimals also can be turned into fractions, which means they're rational numbers. Things that are not rational numbers are values like pi, because pi doesn't equal any fraction, right? E is a number that is an irrational number. It does not equal, it cannot be turned into a fraction. Is that clear?
Yes.
Okay, good. Who can tell me what a rational function is now? This is a rational number. What's a rational function? We talked about that when we talked about rational functions a couple weeks ago. Probably feels like a couple years ago at this point, but it was only a couple weeks. Anybody? A rational function is a polynomial over a polynomial. Remember that? Somebody say yes, I remember.
Yes.
Oh, good. Are you telling me the truth? Okay, never mind. So here we have a rational number, and notice here, really, as x goes to infinity, whatever r is, as long as r is a positive number, this function is going to always go to 0, right? The bigger the denominator, the smaller the value, right? And the same thing is true even if you're going to negative infinity. Because if I were to graph, let's say I were going to graph 1 over x, for example, I have this horizontal asymptote at 0, and it doesn't really matter if I'm going to positive infinity or negative infinity. I'm still going to 0, even though to the right I'm going to 0 from the positive direct, from above the x-axis, and to the left, at negative infinity, I'm going to 0 from below the x-axis. They're still both going to 0. Does that make sense? I'll say
yes.
Yes. Okay, good. Thank you. So we did this when we talked about horizontal asymptotes, and we really already know the answer to this. If I ask you what's the limit as x approaches infinity, hopefully you remember that I said you just look at the leading term over the leading term, which is 3/5, right? But that's only true if you have a rational function, which is a polynomial over a polynomial, which is what I have here. Well, let me show you another technique now that we use in calculus to solve this. So
I have a question, Ms. Greenberg. Oh.
Yes. Yeah, sure, Joey.
Does the degree of the polynomial have to be the same? I don't know why it's echoing so bad.
No.
It doesn't. It could be 3 to the third over 5 to the, or whatever.
Yeah, it just depends on what it is. And then what we want to do is find the limit, okay?
Okay.
And of course, it'll be different values depending on what for this problem specifically, it's going to be 3/5. But let me also show you how we can prove that using calculus now. So what I want to do here is, first thing I'm going to do is I'm going to multiply this by 1 over x squared over 1 over x squared. And why do I do that? Well, let's see. Let's look at this, and we can say this is the limit as x approaches infinity. And I'm just going to multiply this out, and I get 3 minus 1 over x minus 2 over x squared over 5 plus 4 over x plus 1 over x squared, right? Is that clear? Okay. So now, what's going to happen here? What does 1 over x equal as x approaches infinity?
0?
Yes, exactly. And what does 2 over x squared equal as x goes to infinity?
Super 0.
Super
Ms.
0,
Greenberg,
exactly, yes.
why are you able to, where are you getting the 1 over the x squared from?
What I'm going to do is I'm trying to like eliminate some of these terms, okay? And notice here, if I multiply by 1 over x over 1 over x, then I get 3 and 5 as my first values. And what's happening for the rest of the terms is they're going to 0 because when I multiply, I get 1 over x and 2 over x squared, right?
Yeah.
You see what I'm doing, Jake?
Basically use any large arbitrary number.
I was just asking how you got the original 1 over x squared, like next
Well, I
to
looked
the.
at, I have this is my largest variable.
Yeah.
So if I want to get rid of my largest variable, I would have to multiply by 1 over x squared, right?
Oh, so like if the largest variable was x to the 3, then it would be 1 over x to the 3.
Yeah.
What I've been
Okay.
doing is
It's just 1 over the largest variable.
or 1,000.
Wait. Logan, you can't talk at the same time as Jake. Jake, finish what you're saying, then I'll answer your question, Logan.
So it's just always 1 over the largest variable.
Pretty much, yeah. I think I could say that. I'm trying to think of all kinds of possibilities, but I think that could be true. You'll get some experience with this, but yeah, probably. Okay, Logan, go ahead.
Well, basically what I've been doing with these problems is make x equal like a big number, like 1,000 or a billion.
Yeah, but we don't do that in calculus because 1,000's not very big compared to infinity, right?
Well, yeah, that's what I was saying. I was going to say 1,000 or a billion. Basically, what I'm trying to do is like use a large number where all the
No, you just want to. That's not what you want to do. That's not what you want to do. You want to do what I'm doing. You can think of it like that if you like, but I want you to do what I'm doing.
All right. Just using that notes to understand the problems better.
Okay, that's fine. If that helps you, I'm not saying don't do it. I'm just saying I want you to even Like, so with calculus, it's a little tiny bit more abstract things. There's some things that are a little more abstract. I know that's hard, but I'm trying to start to expose you to those things so you don't kind of panic when you get to calculus, honestly. And then I can say in the denominator, the same thing is true. This goes to 0 and this goes to 0, right? And what do I have left? I just have 3/5 left. And that was what we said our horizontal asymptote was going to be anyway, right? So do you all kind of see what the point is here about what I did?
Yeah.
Okay, good. Let's go on. So now, and if you notice, this is a polynomial over a polynomial, which makes it a rational function. Is this a polynomial over a polynomial? That's a real question.
No.
No, exactly. Polynomials don't have square roots in them, unless it's just the square root of a constant, right? Because that's a real number. But it doesn't have just square roots of variables. So what we have to do is figure out what to do with this. And if I use the last problem as an example, well, first of all, I want to say that to find horizontal asymptotes, I need to know what the limit as x approaches infinity of some function is. And I also need to know what the limit is as x approaches negative infinity of some function. And the only time that these are definitely the same is when we have a rational function. It may not be true if I don't have a rational function. And here I don't have a rational function, so what I can have is more than one asymptote, horizontal. We've only dealt with one horizontal asymptote in the past. Now I could have more. Okay? Does everybody understand so far what we're saying? What I'm saying?
Yes.
Yeah.
So, okay, good. So now, the positive infinity one is pretty easy. So I'm just going to say this is equal to 2x squared plus 1 over 3x minus 5. And notice here, I want to know what the limit as x approaches infinity of this function is. Now, again, I want to be able to get this to a point where I can figure out the answer. So I see that I have an x in the denominator, and I have an x squared, but I have a square root of x squared. So what I want to do is I want to say, well, let's see. Can I say that 1 over x is equal to 1 over the square root of x squared as long as x is greater than 0? Is that true? Does anybody think that's true? Does anybody think that's not true?
No, it's definitely true.
It's definitely true. Okay, good. So what I can do here is I can multiply by 1 over the square root of x squared over 1 over x, which is still 1 over x over 1 over x, right?
Yes.
Perfect. And then I can say this is equal to the square root. I'm just going to multiply them together. Right? Does that make sense? And then this equals the limit as x approaches infinity of the square root of 2 plus 1 over x squared over 3 minus 5 over x. Is that true?
Yes.
Yes.
Good. Now what happens to 1 over x squared as x goes to infinity?
Wait, question.
Yeah.
For the top part, do you not keep the radical over the x squared under 1 over x Oh, kidding. Okay, never mind. I think
So here, let me just say, if I have the square root of 1 times 1 over the square root of x squared, that's equal to the square root of 1 over x squared, isn't it?
yes. There we go.
That's all I did.
Okay, yeah.
Okay, good. No, you can ask me those questions. It's fine. So everybody's okay here, right? But now as x approaches infinity, this goes to 0, and this goes to 0, and I end up with the square root of 2 over 3. Yes?
Right.
Any questions yet here? Okay, so I have to erase this because I have more things to do, because I've only found a horizontal asymptote as x goes to positive infinity. Now I want to find out what happens as x goes to negative infinity, okay? So I'm going to erase this. Try to erase it. Okay. So now, let me erase this. It's hard for me to figure out what to do. It's not as easy as you think. It should be easy. Okay. So now we want to figure out what is the limit.
If only you had a whiteboard.
Excuse me?
If only you had a whiteboard.
I know, right? So then I have this actually works better than the whiteboard they give me. Okay, so now I have this, and I want to know what happens as I get to negative infinity. Well, I can say that, is this true? If x is less than 0? Is that true?
No, because you can't get a negative number.
Right. So can you think of some way for me to make that more true or true instead of not true?
Doesn't exist?
No, it does exist. I can actually make this a negative number. So now if x is negative, let's say x is equal to negative 2, right?
Mm-hmm.
So I have 1 over negative 2 squared, which is the same as 1 over the square, 1 over the square root of negative 2 squared, which is the same as 1 over the square root of 4, which is 1/2, right? And then is that equal to negative 1 over negative 2 is, again, equal to positive 1/2. So that's true, isn't it? Is that true?
Are you writing something down? I can't see it.
You can't see what?
Are you writing anything down?
No, I wrote this. I just want to make sure everybody agrees with me that this is true.
Oh, okay, just making sure.
Yeah. I didn't write anything there. Is that true?
Oh, yeah, that is true, because you have the positive and the negative. Okay, yeah.
See it? So everybody sees that now, right? Okay, good. So now I can say, well, if these are equal when x is less than 0 and I'm going to negative infinity, I can multiply by 1 over the square root of x squared over negative 1 over x, right?
Okay.
And then I can say, again, this is the same. I can say this is equal to 2 plus 1 over x squared over negative 3 plus 5 over x, right? And then this goes to 0 and this goes to 0. So I end up with the square root of 2 over 3, only the whole thing is negative. Yes?
Yes, it's a little mind-blowing how simple it seems.
Right? So it's not that bad, but this takes a little bit of thought, right? This part right up here takes a little bit of thought. So let's see, I have another way that I do it. I don't want to confuse you, so I wanted to show you how it works. But let's do this. I'm going to erase this again. So if I have the limit as x approaches negative infinity of x, I can say that's equal to negative infinity, right? And if I have the limit as x approaches infinity of negative x, that's still equal to negative infinity, right? So notice, if I change my positive x to negative x, everything's going to stay basically the same, isn't it? So sometimes it's harder to work with negative infinities than it is positive infinities.
Why is that positive and negative or x equal the same negative infinity though?
Well, what's the first step when you want to find a limit?
You plug in, right?
Plug it in. So if I plug in negative infinity for x, what would I get?
Negative infinity.
And if I do the second one, if I plug in infinity for negative x, what am I going to get?
Oh, negative infinity. Okay.
So they're really the same, right?
Yeah.
Now, that's also true. I can say that the limit as x approaches infinity of the square root of 2 times negative x squared plus 1 over 3 times negative x minus 5. Notice what I did is I plugged in negative x for every x. So this is the same as the limit as x approaches negative infinity of just x. Does that make sense?
Mm-hmm.
Okay, good. Now this is equal to the limit as x approaches infinity of the square root of 2x squared plus 1 over minus 3x minus 5. Right? And now I can do the same thing as I did before, where I multiply by 1 over x squared over 1 over x, and I'm still going to get the limit as x approaches infinity of the square root of 2 plus 1 over x squared over minus 3 minus 5 over x, where these two go to 0, and I still get minus the square root of 2 over 3. So either way, I get the same answer. This technique right here sometimes works better than the others. You can have some really strange functions that you're given, and sometimes it's hard to think through exactly what's happening everywhere. But what I did before also works.
Okay, so I have a question, Ms. Greenberg.
Yes.
So remember how we found for the top part, you multiply it by 1 over the root of x squared?
Uh-huh.
So when you pull out the negative, for like the bottom part, when you pull out the x and you make it negative, do you still multiply it by the same multiples? I don't know if that makes sense.
It did. I want to answer your question, but I'm not sure I understood it completely, so I don't want to answer.
So in the first way, you explained it how it's like negative 1 over x?
Yeah, like up here. Like right at the top here. Yeah.
You make the bottom 1 over x negative.
Yeah.
Correct.
So because that's how it's true.
Okay. So
but now if I change it to positive infinity, I don't have to worry about those negatives anymore.
Okay.
Because my limit's going to positive infinity, not negative infinity.
Okay. No, I'm saying though for the negative part, if you did it Okay, I get what you're saying. Never mind. I got it.
You got it?
Yeah, I see it.
Okay,
I get it.
Okay, cool. Is there any other questions? Very good, Joey. Any other questions? Okay, so let me erase this because I haven't done vertical asymptotes yet. So I'm going to erase this. Everybody has this? Okay, perfect. So now I want to deal, so I took care of my horizontal. Now I need to take care of my vertical asymptotes. Okay, so do I have a vertical asymptote here?
Yes, you, no. Wait, yeah, you will.
Okay, if I do, where is it? And if I don't, why don't I have it?
Isn't a vertical asymptote anything that makes is it the numerator equal to 0?
So if I have x over 5, does that give me a vertical asymptote if x equals 0?
No.
No. So that's not it. It's the denominator.
It is the
That's
denominator.
undefined.
That's what
Yeah,
I
because
thought.
it's undefined when the denominator equals 0, right?
Uh-huh.
So I have a vertical asymptote at 5/3. Agreed?
Yes.
Good. So now let's look. Here's my vertical asymptote. It's at 5/3. Now, do I have any zeros in this function? So what I mean by that is there any place where the numerator equals 0, because that would be 0 over something, which would make it 0, right? So can the numerator equal 0?
Yes, the numerator can equal 0.
What value of x gives me 0 in the numerator?
Because it's
Not
squared, wouldn't it be hard?
There's two people talking at the same time, so go ahead. One person at a time.
I said, isn't it not because of the square root?
Well, if it was a square root, can a square root of x be equal to 0?
Yeah,
When?
at 0.
At 0, right? So basically, I want to know, do we have 2x plus 1 has to equal 0, right?
Yeah.
But
That
how can
can't
it when it's
happen.
x squared?
Right, because x squared is going to be positive, so a positive number plus 1 is definitely not going to be 0. So we don't have any zeros. So it's important to find zeros, because if there was a 0, I'd have to, like, let's say there was a 0 here in the graph, well, I'd have to find a number between that 0 and my asymptote. But since I don't have any zeros, I can actually, how do I find out if this vertical asymptote is going to positive or negative infinity? Right? Remember, what I really want to know is, what is from the left, I'll just write f of x instead of writing it all out. What does that equal? Right? I'm trying to find these two things if I want to decide what happens at that vertical asymptote. Do y'all agree with that? Yeah, because remember from the last lecture, either if you have a vertical asymptote, either they're going to positive infinity or they're going to negative infinity, or they can go, one can go to positive, one can go to negative, or vice versa, right?
Yes.
Remember that? Remember that? Good. So how do I figure out if from the left or on the left side of the asymptote, if it's going to positive or negative infinity? Does anybody remember how to do that?
Can you first plug in, like,
Well, if you plug in 5/3, what do you want to plug in?
a number right before 5/3?
Oh, that's a great idea, Joey. Perfect. So let's plug in 1. That's 3, 4, 5/3, right?
Yeah,
So let's say when x equals 1, and I don't really care what the number is, I know the top is always going to be a positive number because it's the square root. And here, the denominator is going to be negative when I plug in 1, right?
Yes.
So that means this is going to negative infinity because this is equal to a negative number.
Mhm.
Does that make sense to everybody?
Yes.
Perfect. Perfect. And what about from the right? What number can I use from the right?
2.
Perfect. So let's plug in 2. Well, I already know the numerator is always positive. And if I plug in 2, I get a positive number. So this is equal to a positive value. That means I have negative infinity and positive infinity. So if I were to graph this, if I wanted to graph this graph, which that's not what I'm asking you to do. You will not be graphing things. I just want you to have some understanding. So I have this horizontal asymptote here at 5/3, right? And I also have a horizontal asymptote. Did I say horizontal? I meant vertical if I said horizontal. At 2 over the square root of 3. And I have another one here at minus 2 over the square root of 3. And let's see what I know. I know it's going to positive infinity. No, wait. It's going to, when x is 1. So here it's going to negative infinity. And then it's going to go something like this, right? And on the other side, it's going to positive infinity. And it's coming down to this minus 2 over the square root of 3. So I'm not saying this is exactly what it looks like, but I have some idea now of what this graph is looking like, right? Because I found my asymptotes and what's happening around those asymptotes. Does that make sense to everybody? Yes? But
Yes.
you will be graphing in calculus. You will not be graphing. I just want you to see what we're trying to find. Okay. So now here's the actual picture of what it looks like, which is kind of what we thought it should look like. We didn't know it had that little, like, bump here, because that's something you could figure out in calculus, but you can't figure out without calculus. But we had a pretty good sketch for not really doing much of anything, right? Any questions? Good.
Yeah, I do have a question actually.
Okay.
How do you know, from looking at that graph, how do you know if it stays on the top or the bottom part of the asymptote, or would it really matter in this case? Because we just want to know which way it's approaching.
Yeah, all we know right now is very little, truthfully.
Okay. Yeah.
Honestly, we don't know that much. But
We just know the asymptotes and where it's approaching towards them.
Yeah, exactly.
Okay.
Exactly. Okay.
So we won't need to exactly know if it's on the top or the bottom of the asymptote. Does that make sense?
You won't need to know. You're not graphing anything yet.
Okay, true. Okay.
Like in this class, we will not be graphing these things. You will be graphing things in calculus. And I think I actually got this, like the graph on the last one, wrong because, yeah, I had this backwards. This should be going to negative. This should be going like that.
Okay.
That should be going like that. I just didn't have those other values written down, so I forgot that I had them in the opposite direction. Right? Because positive infinity was going to positive 2 over the square root of 3, and negative infinity was going to negative 2 over the square root of 3. So it would look more like this.
Okay.
Which is obviously what this looks like. Okay?
Cool. Yep.
Good. When you have a polynomial over a polynomial, which is a rational function, you will only have one horizontal asymptote. Right? We learned that when we did graphing rational functions, we always had one horizontal asymptote. But you could have multiple horizontal asymptotes if you don't have a rational function. So this one is going to have, notice here, if I look at the leading term over the leading term, I have 3 over x. As x goes to infinity, that goes to 0. I have my horizontal asymptote here at 0, which is the limit as x approaches negative infinity to positive infinity of f of x both goes to 0. Clear?
Yes.
Good. And here we can see that the limit as x approaches infinity or positive infinity of a cosine graph, well, we don't have a horizontal asymptote. And it's not going to any particular value. It's just oscillating back and forth. So it's not approaching any value at infinity or negative infinity. So this would not have a horizontal asymptote. Clear?
Clear.
All right. Good. We're almost going to get done with this, guys. You did good. This is taking way shorter than my morning class. So, good. Are you all understanding everything?
Yes, pretty well.
Pretty much?
Yeah.
Okay. I mean, of course, I know you need to do some of it on your own, but I just want to make sure it's making some sense. All right. So now let's look at e to the x. So this should make sense that if I say e, which is some constant, to a variable, as x gets bigger and bigger, the e to the x is going to get bigger and bigger, right? And it's going to approach infinity. That should make sense, right?
Mm-hmm.
Can anyone tell me why this is 0 when it goes to negative infinity? Can someone explain that one to me?
Isn't it because there's a horizontal asymptote at 0?
Better explanation. But that's only because the limit goes to infinity, negative infinity. Like, I want an algebraic answer. Like, what algebra can you tell me? That, you understand what I'm saying?
Yeah, because, so we said earlier that if x was negative infinity, right? If x equals infinity and negative x also equals negative infinity, so if we plug e to the negative x, would that give you 0 instead of?
So yeah, you could say, I think I understand what you're saying, Joey. You're saying I could do this. Is that what you meant?
Yes.
Yeah. So what is e to the minus x equal? What's another way to write e to the minus x?
E to the, why am I blanking out?
What's another way to write 2 to the minus 3?
Oh, e to the 1 over x. Oh, like
Try one more time.
E to the power of 1 over x.
Try it one more time.
X over 1? X over 2.
Not square root, Chris. So what is e to the minus 3 equal? I mean, 2 to the minus 3 equal, Joe?
Isn't it 2 to the 1/3?
No. No. You're getting things mixed up. Anybody? Come on, I have a whole class. Somebody's got to know.
Isn't that 1 over 2 to the third?
Yeah, it's 1 over 2 to the third, right?
It's 1 over
It just
e.
puts it into the denominator, so this would be 1 over e to the x, wouldn't it?
Oh, wow. That's tough. Like,
so this is 1 over e to the x. And now, as x approaches positive infinity, what's happening?
it's 1 over a very large number.
Which is 0.
Yep.
That's why that's that way. Okay, makes sense? And then here, it's really the same thing, only kind of in reverse, which is kind of like what we did here, right? And who can tell me about the third one? How about ln? Why does ln of x as x approaches 0 from the right equal negative infinity? So this one it's easier if I show you the graph of the log. So for this one, let's look at the graph, right? That's the graph of log. This is 1. Remember that? So everybody please say yes. Oh, good. So as I get closer to 0 from the right, this gets closer and closer. Remember, we have this this vertical asymptote here. So this goes to negative infinity. And as it gets bigger and bigger, this value just goes to infinity, right? It doesn't get, there's no asymptote there. It just gets bigger and bigger. Does that make sense?
Yes.
What if I said the limit as x approaches 0 minus of ln of x? What does that equal?
It would still be 0.
No.
How can it approach 0 from the left? It's already past 0.
Right, so this does not exist. There is no part of the graph on this side. Remember, for ln, x has got to be greater than 0. It was a little bit of a trick question, but I wasn't trying to trick you. I was trying to point things out to you so that you can understand things. Okay? Everybody understands this?
Yep.
Cool. I don't want to do this one. Let me do this one. We're going to finish early because I don't want to go ahead of my morning class. Okay, so how would I do? Somebody else. Jordan, pick on somebody. I can't see anybody. So don't ask Joey, who is Umberto. Don't ask Michael. We always ask Michael everything. Don't ask Emily. People who have talked already, don't ask. Somebody new.
I was muted. Carter.
Carter's a great person to ask. All right, Carter. Can you hear me? Can you talk? Carter? You have to unmute yourself. All right, no Carter.
QQ for Carter. Then Layla.
Perfect, Layla. If you get this wrong, Layla, you got to sing "Happy Birthday" to Jordan all by yourself.
You really don't.
I'm just kidding. I'm just kidding.
Who said it was their birthday?
It's my birthday too.
Layla, it's your birthday too?
Yeah, it's today.
That's
oh
so crazy, Layla.
Well,
It's really not.
To you.
Because it's like a 1 out of 365 chance, but that's so crazy.
No,
Yeah.
it's really less than that. It's a really weird thing. It's very, very weird, but it's less.
The actual
Well, happy birthday, Layla.
Thank you.
Pretend like we all sang happy birthday to you as well.
I will.
Okay, great. Sorry about that. So,
I will.
all right. Are you the same age? No way. Never mind.
No, I'm turning 19.
You're turning 19?
Yeah.
Well,
I'm
what's
turning
the
19.
coincidence?
Oh.
Coincidence.
That's a
Where were you born?
coincidence.
Where were you born?
I don't know where I was born.
Come on, Jordan.
Where was Layla born?
I was born in New York.
Oh, I wasn't born in such a cool place. I'm not
Okay.
gonna say.
All right. Well, let's get back to work. But happy birthday to both of you. Okay. So Layla.
Sorry, Layla, on your birthday of all times.
Don't worry, it's okay.
Layla doesn't mind. Yeah. Any ideas?
So we're finding the horizontal and vertical asymptote, right?
No. We just want to know what the limit as x approaches infinity.
Oh, okay.
That's it. Just one question. You don't have to do all of it.
Okay, so the horizontal asymptote is 1.
And then that's the horizontal asymptote. How do you find we have to do some math here.
Wait, what did you say?
We're not talking about the horizontal asymptote. This is just a problem.
Oh, okay.
So what can I do algebraically? I'll even give you a clue. You were right. The answer is 1. How do I do the algebra?
Okay.
Prove it.
I was thinking of graphing it, but I don't think that'd be a good idea.
No, you don't want to graph it. That's way harder than you need to do.
I would just plug in infinity first.
Okay, and what would you get?
You get infinity plus e to the negative infinity over x.
Over infinity.
Yeah.
Okay, good.
And e to the negative infinity is 1 over e to the infinity, right?
Okay, so here's what I would recommend. Because infinity over infinity is not really something you can, there's different kinds of infinity, believe it or not. And so if you say infinity over infinity, it's not necessarily 1, okay? So I wouldn't do it like this, but what I would do is I would say this is equal to this.
Okay.
Okay, good. Now, I already learned what 1 over the limit, so what's the limit as x approaches infinity of 1 over e to the x?
That's 0.
Right. So this goes to 0, and now I have the limit as x approaches infinity of x over x. And x over x is 1, for sure.
Yeah.
So I can say that the limit here is 1.
Okay, that makes sense.
Perfect. Great job, Layla. Thank you very much. Happy birthday again.
Thank you.
It's so exciting. You're both birthday people at the same day. I wonder if you guys must be more alike than we know. All right. So that's it. Any questions?
I have a question about that last problem.
The one before this one?
No, this one. So,
okay.
So when we substitute, we plug in infinity for everything. But in this case, like if you knew e to the negative x is equal to 0, then you would just be left with, or you wouldn't really be left with anything. But like you'd be with x plus 0, which would still be x. Yeah.
Right.
So,
yeah, it's x over x.
Okay. And then, okay, never mind. I thought you were doing the limit as x approaches infinity from 1 over e of x. Okay, I see that.
You see it now?
Yeah, you just put it next to the limit, so I was confused. I was like, wait a second.
Wait, I just want to make sure you're not confused anymore.
No, I'm good.
Okay,
I get it.
perfect.
Yeah.
Perfect. Any other questions? All right, good. I'm going to close this up, and let me see who's left here. So here, I'm going to stop the recording.